My name is Colleen Larson. I'm the Regional Dairy Extension Agent for the University of Florida IFAS in South Florida for dairies in this area. I am housed in Okeechobee County, and I work with dairies in the surrounding counties of Okeechobee, Highlands, Hardy, Glades, St. Lucie, and Manatee County. So that's kind of my area of, where I work. So obviously today's topic on, something to help with heat and the continuing issue that we have of climate in this area with dairy cattle and cattle in general is pretty pertinent. So this study has been going on long before I got involved with this in the last couple years. The SLIC gene was identified in cattle. Whoops, let me see how to go forward now. There we go. Okay. So the SLIC gene was identified in cattle back in the 1970s, 1980s, and the first place it was identified was in Senepol cattle in the British Virgin Islands in St. Croix. These cattle were noticed to be obviously, they had a slick hide, but they didn't have the other characteristics of a Bos indicus breed. They had more of the European type composite breed of, different cattle, but they had that slick hair coat. And as we'll see in some of the other pictures, some other characteristics like the wrinkly forehead that's noticeable on the Senepol cattle. Continuing after this was noticed in the Senepol cattle, several other breeds in this similar area of the Caribbean islands and South America have had similar characteristics. So to date, there are 6 different mutations that have been identified that cause cattle to exhibit shorter hair coats. Again, the first one was in the Senepol, and then the other ones were in, again, breeds that originated from Spain or other European countries, with the exception of Puerto Rico. So Puerto Rico has Holstein cattle that have the same SLIC mutation as Senepol cattle, but it's really not known where that where it came from. So if it was done intentionally, if it was a mutation that happened in Holstein cattle on the same location as the Senepol, which would be quite fascinating, or if it happened similarly to what developed here in Florida on purpose, obviously, and then it just persisted because of the advantages of those, of those SLIC characteristics. Okay, so how does it happen? It was a spontaneous mutation from all evidence that caused the prolactin receptor to be shorter. So prolactin is a hormone that promotes mammary growth, causes lactation to have to start and persist. And it also inhibits hair growth. So prolactin has some, additional functions other than the mammary growth and support. And the 300 other functions, I don't know what all of those are, but it's important as we go on that we, make sure that those are taken into consideration, because obviously if this is a prolactin receptor that's being affected, by this SLIC gene, we need to make sure that we're not having other consequences down the road that we kind of, that we can't take back after the incorporation into cattle to help them with their thermotolerance. So the prolactin receptor is it's a truncated or a shortened version of that receptor, and for whatever reason, which is unknown to this point or not quite known to this point, there's a lot of work being done on that right now. It causes the feedback for them to have shorter hair, and then some other skin characteristics again that are being researched. So cattle have, two of these genes, and they can have normal hair if they have 2 normal prolactin receptors. or if they have one copy of this SLIC mutated prolactin receptor. And for this one, we're talking about this SLIC1 mutation that is seen with the Senepol cattle and with the Holstein cattle. They will exhibit the short hair, so whether they have two copies of it or one copy of it. So for most of the research that I'm going to talk about, the animals in this research have one copy of the mutated prolactin receptor that they received from their sire. All right, so in Florida, this kind of started back in the 1980s with a combination with a dairy that was down in Plant City and with Dr. Tim Olson, who was at the University of Florida. So the dairy in Plant City was working with a AI representative who gave them some straws of Senepol semen just as a favor or as a bonus. I'm not sure the whole story. I've heard it secondhand a couple times. And the owners of that dairy, the Perkle family, kind of as their own experiment, just decided to use those, those straws on some of their Holstein cattle. And what they noticed was that several of the offspring had shorter hair. Obviously, there wasn't a whole lot of research being done at that time on the full genome. That came later on, where we could identify where that mutation was, and that's how those SLIC 1 through 6 have now been identified. But at that time, it was the phenotype that was noticed, that they had a shorter hair coat. And obviously, in our climate, that was encouraging, that it might help them stay cooler in our warming up climate. So Dr. Olson was working with this dairy and noticed some of these animals, got the story, and eventually what happened was that they decided, the University of Florida Dairy Research Unit decided that they were going to purchase these animals from Pine Valley Dairy and continue to do research on the potential that they could, help improve thermotolerance in Holstein cattle in our area. So the animal on the left was one that was bred at Pine Valley Dairy from that semen from the Senepol cattle that was, given to them. In the center there, that's a Senepol, just a traditional Senepol that has the very short hair and the wrinkly head. Dr. Olson's there on the bottom. I'm not sure about that cow. Maybe it was a combination. Maybe that was an early cross between a Holstein and a Senepol, but I'm really just guessing there. And then over on the right is one of the SLIC Holsteins. It's heterozygous for the SLIC gene that is there at the University of Florida now. So after the interest in the development of that, the University of Florida, continued to put a lot of interest and effort into developing these animals. Since this was done through just natural breeding, obviously the Senepol cattle did not have the characteristics of a Holstein that we would want in high milk production. So it took many, many years to get to the point that we had the gene persisting in Holstein cattle, in a animal that would still have viability as a Holstein for producing milk. So 35 years after that first cross between the Plant City Dairy and the University of Florida, the first commercial SLIC bull was produced, and that was almost 7 years ago now. So this was actually one of the bulls that was used in the current research that's ongoing. So that's SLIC Gator Blanco, and most of the studs have been developed through some cooperation with the University of Florida, or they were developed by the University of Florida. So that's obviously where the gator comes from. All right, so moving along, we had those animals at the University of Florida for several years, just in very low numbers. So this first graph just kind of shows the difference between the animals that that got the SLIC gene. So the lower portion of this graph, these that say SLIC here, there were 16 of them identified as having one copy of the SLIC gene, and this is their vaginal temperature throughout the day compared to animals that did not have the gene and compared to animals that were siblings of these SLIC animals but did not inherit the gene. So that kind of takes away the variation of just the difference between animals. So we know that there is a lot of variation between heat tolerance and just individual animals, and that's another area that's being looked at. But with comparing the half siblings, so these open circles on this top portion of the graph, to the animals with the SLIC gene, obviously, we can tell here that the lower vaginal temperatures and in turn increased heat tolerance is due to that them inheriting that SLIC gene from their sire. The next thing that they looked at on the dairy research unit with these animals was just the difference in milk production on cows that were born in the summer months versus cows that were born in the winter months. Now, obviously, our summer and winter is changing, but we've seen a big difference in peak yield of milk production from animals that are born during that hot time versus animals that are born when it starts to cool off and they reach that peak or summit milk during the cooler parts of the year. So on the top part of this, we have we have animals. It just shows the normal variation in milk production for cows on the bottom portion where they calve in the summer, so May through July, versus cows that calve in the winter, October through December. If we were, gonna repeat this study, we might want to push that back to November through January or even farther back, because obviously, we're definitely seeing those summer temperatures persist through October, especially, in our area in, well, most of Florida, but especially in South Florida, that we don't have that cool down until much later in the fall. So that's the normal variation, and these are both animals on the top graph that none of them contain the SLIC mutation. Now, if you look at the bottom portion of this graph, these are all SLIC animals. So while there's still quite a bit of variation, it kind of takes away that seasonal difference. You don't see the distinct difference in animals that were born in the summer versus animals that were born in the winter. Now, this is only 18 animals, and so there's some limitations on what can be, proven from this or realized from this, but that's why we're continuing with larger amounts of animals in the next studies that we'll look at. Okay, so this is the results of ruminal temperatures on Holstein heifers that were in weaning lots in South Florida in the summer. And the difference was, and these are where it says wild type there, this group of heifers were all of the heifers that were identified that were bred to SLIC sires, but the ones in the blue were the ones that received the gene or the mutated gene, the SLIC gene, from one of the SLIC sires that was used in this study. So there was a pretty obvious difference in the ruminal temperature throughout the day. We noticed some spikes, throughout the day. That 8 a.m. drop is when those animals were fed. So that was feeding time, and obviously after they feed, they go drink water that, is going to be a little bit cooler, so that 6 a.m. to 10 a.m. drop is their feeding time, and then, probably when they went to drink water after that. All right. Here's a couple pictures of some of the animals that were used in this study. The one on the right is probably the best one. You can see the hair or the lack of hair across her, from her poll over her withers and across her back. The hair on these animals is extremely short, and especially in this area where they usually have all of this, kind of fuzzy hair across their withers. So several of the things that were done in this study were, identifying whether they appeared to be slick or not, and then matching that to the, to the genetic sample, which was those genetic samples were run by zoetists to determine if they had the slick mutation. And then there were skin samples taken for other purposes. So the skin samples were to determine how many sweat glands they had in that area, and if there's a difference between the number of sweat glands, their sweating rate on the area that was that had hair and that did not have hair was determined for the slick and for the wild type animals. So, really just trying to identify how this is happening. Is it just the short hair coat, and what are the other factors that could be going on with these animals to cause this increased heat tolerance? So the most recent study, this was a multi-state, multi-farm experiment. I think it was 750 breedings, obviously not that many pregnancies, but 750 breedings between 4 California dairies and 3 Florida dairies in South Florida specifically. And this started back in 2019, and the goal, well, actually 2018, the goal was to have 2 different groups of calves born. So group 1 calves were born between November and March. And again, this is to try to see the effects of calves that are born during the cooler months. And then the next group of calves were born between June and July of 2020. And that was to look at the, how the calves responded when they were born, basically, during the warmest time, and they were going into definitely the warmest time of the year in their early days. So, we've got a lot of other things going on in this. When they were pregnant, obviously, is going to affect, the offspring. So we've seen lower birth rates on cows that are pregnant with calves during the hottest time of the month or the hottest time of the year. So there's a lot of other factors in here, but this was, basically just to look at these animals born at different times in California versus Florida, kind of to see where this slick, the benefit of this slick mutation is, most likely to be. So the first thing that we noticed in this study was that all of the slick animals had a higher tolerance to increasing temperature humidity index. So this is with all of the slick animals from Florida and all of the slick animals from California combined. And you'll notice that the slope of the line on the slick animals is much more gradual than the slope of the line on the non-slick animals, as that temperature humidity index really approached those critical levels there up in the mid to higher 80s. The ability of those non-slick animals to regulate their heat really just disappeared. So you'll notice some outliers in both of the groups. One of the things that we did not take out of this was individual animals that may have had a fever for another reason, if they were sick or something like that. So obviously there's some pretty high temperatures in both the slick and the non-slick, but the slope of the line just indicates that the non-slick animals were that the slick animals were better able to continue to regulate their body temperature as that temperature humidity index increased to those really high levels. We didn't expect to see any birth weight difference in these animals. There's no reason to, they were not calving. Difficulty scores were similar. There was a small tendency to see that the slick animals in Florida were heavier, but there's not really any explanation, and there really shouldn't have been any difference in the birth weights of these animals. So again, this is just it's a little harder to see in this one. That's why I like this picture. I guess that's why I included it twice. This one, you can see that this animal just has a lot of hair across her back, whereas this one, maybe it's just because she's under the light. But you can, you don't notice all of that fuzzy hair along her back. So it's very obvious when you see them in person. In pictures, it's a little harder to tell, but hopefully in this one, you can, just really notice that obvious, difference in the phenotype. All right, so moving on to the what we saw in this study, it became really apparent that the benefits were much more pronounced in Florida, and we'll talk about some of those reasons. Obviously, we have similar high temperatures during the hot parts of the month or during the hot parts of the year, but what we really saw in the difference between California and Florida was that the humidity in Florida was higher the entire time, which of course increased that temperature humidity index where they were under heat stress the entire day, and they never really got a break from the humidity in the afternoon or the evening, and the nighttime temperatures didn't cool off. So in California, we used hobo devices in both locations, and the temperatures at nighttime in California would drop significantly, whereas in Florida, we don't have that cooling off overnight. So when these animals were exposed to heat day and night, the difference between the slick animals and the non-slick animals in their ability to regulate their heat was just a lot more obvious in Florida. The other thing that we noticed was that group 1 versus group 2, the group 1 calves had a much higher body temperature than the group 2 calves in Florida. These were the group 1 was the older animals, and these were we don't have a whole lot of explanation of why that happened, but those animals were obviously not as good at regulating their body temperature. Now this is overall Florida, not just the slick animals. So we've got quite a few animals in that group that were bringing that number up quite a bit. Respiration rate followed a similar pattern. There wasn't a big difference in respiration rate, other than obviously it was higher in Florida, again, as those calves are under constant heat stress and just never have the ability to cool off at night or have those lower humidities that brings down the temperature humidity index. We notice a lot more panting and a lot more, just environmental stress. The respiration rate in those Florida calves from group 1 versus group 2 followed the same pattern as their body temperature, as their rectal temperature, which, would make sense. If they're hot, then they are panting to try to cool down. Another one that, kind of followed what we would expect. Sweating is much more effective in climates where the humidity is lower. So the sweating rate in Florida was definitely lower when compared to California. Those animals were not able to, cool down by sweating, just because the gradient between their skin and that outside air was not enough for it to evaporate. So, that was kind of expected, that the body wasn't going to, kind of waste resources on sweating if that evaporation couldn't happen to help cool them down. So, you'll notice here, that there was quite a bit higher sweating rate in the California animals, both slick and non-slick, versus the Florida animals who just didn't sweat as much. And then the younger calves had lower sweating rates in both states. So, obviously when they're younger, they're not moving around as much. They're, they don't have all of those facilities. And they also don't have the, a younger calf has a lot more surface area, and they are not a ruminant. They're not producing all of that heat from within yet. So their need for and their ability to sweat really starts to come along as they, go out into, the pasture and become a ruminant and start eating grass and have that, heat production coming from within and not just from outside. Okay, so what's next? What are our, goals to continue? We obviously, we know that the slick gene helps to, regulate heat in animals. It is successfully been inserted into Holstein cattle, with keeping the Holstein predominantly still all of the characteristics of a Holstein. This has also been done in Jersey cattle and in Angus cattle. It's been kind of done differently throughout different places in the country. So there's a group in Australia, I believe, that has done this through genetic technology. From this study, what was done here was all done through natural breeding and selection. Moving forward, instead of taking 35 years to develop a bull that, is viable, that technology that can, make that happen in a very short amount of time has a lot of potential to get that gene into animals that are also competitive as far as their milk production and reproduction, just making sure that there's not any other side effects that we get the characteristics of a centipole that we don't want in dairy cattle. So that's really the goal, is to improve these bulls, whether it is through continuing the natural selection, which is already ongoing, or to hopefully have the availability to to do this with genetic technology, with just the insertion of those genes. So with the cattle that I mentioned, and this is a pretty small number of cattle that were looked at, but these were the cattle in Puerto Rico that have this gene that it's been identified. They just don't know exactly where it came from, so there's just a little less information about it. But there's some potential and there's some optimism that, not only will this help with their heat tolerance, but it will also help with milk production, like we saw at the Dairy Research Unit, that the seasonal difference, was not as evident, or just wasn't there with, the time of year of calving. And then the calving interval with the slick animals in this study in Puerto Rico showed a 2-month smaller calving interval with the wild type Holsteins as compared to the Holsteins that have the slick gene. So this is some of the information that is going to be looked at as the animals in this larger study start calving, so their milk production on a larger scale on a commercial dairy, and then also their reproductive performance will be measured to just see if what we see on the smaller numbers is realized when we put these animals into a commercial setting, and then to see if the slick gene persists. So it has persisted in different countries and different mutations for obviously decades or hundreds of years, and so there's an advantage of this gene. And if there's an advantage of the gene, then obviously, we should see it persist in dairy herds once it's introduced. Now, at what level it needs to be introduced for that to persist is obviously, not known yet, but that's, just one of the things that will be looked at. This is a list of the bulls. So obviously, there's quite a bit of interest and quite a bit of activity going on to develop these bulls. You'll notice on here that there's only one of these that is homozygous. And what I wanted to point out on here, it's the one at the bottom here, and this is a bull that is homozygous for the SLIC gene. And if we go over here to his performance, it's the only one on here with a negative net merit. So really, to make these animals, viable in the dairy industry, we have to make them, they've got to be competitive with the rest of the industry for net merit or for milk. And then we obviously, don't want any other negative impacts to reproduction, which is, seen over here in daughter pregnancy rate. So we're always going to have some variation in those, in those animals, but keeping those numbers up. And it seems like having a heterozygous bull who can, who will have a 50% chance of passing that gene on, and then having that gene kind of persist through the generations might be a better strategy than, trying to encourage producers to breed to a homozygous bull that obviously, is going to bring down that genetic merit for milk production and net merit. So this project was, like I said, started many years ago by Dr. Olson, and I just wanted to kind of include some of the people that have done the majority of the research on this. So Dr. Denicol and Dr. Hansen, Dr. Hansen at the University of Florida and Dr. Denicol at UC Davis in California are the PIs on the current project that are going on. But there have been a lot of people that have kind of, assisted in these projects throughout the different phases. There's some side projects going on. We took some liver biopsies of these animals and just to try to determine, what else is going on, what other unknown consequences of this gene, might be, something to look at. So far, everything has been pretty promising. There's not really any big negative effects of the gene that have been realized so far. But obviously, there's still work to be done on that. But the big things that we are, looking at moving forward is the milk production, and then their reproduction, and then that gene's ability to persist in the herd without us, kind of including more animals into the study. So that's kind of where we are now. So the funding for this project, the primary source of funding was the Holstein Association, and then there was additional funding from the USDA and the Red Larson Endowment at the University of Florida. And with that, I'll put up my contact information, and I would be glad to answer any questions.
Okay, thank you, Colleen. So those of you that may have questions, you can enter them at this time in the questions panel. And while we're giving you a minute to enter those questions, I am going to share with you a few upcoming events. Our next Ona Highlight is going to be with PhD student Jaime Garzon. He is a student of Dr. Joe Vengermini, and he's going to be presenting ecosystem service of overseeding astronomy into Bahia grass pastures. Again, that is March 8th. And then we have a couple of events coming up in March. The first is going to be on the 10th, and that is the Forage Management Tour and Workshop. That's going to be held at Mudge Ranch in LaBelle. And as you can see, the registration is $40. And whenever I send you the recording for today's webinar, I will include this flyer in the next one. So you'll be able to register for those if you're interested. And note on this one that there are CEUs available. So if you need those, this is a good way to get them. The next program in March is on the 31st, right here at the Research Center in Ona. That is going to be a full day program, Environmental Lands Management. This is going to include several speakers as well as lunch and a tour here of the center. The cost for registration is $50. That includes lunch and your handbook. And I'll include the link for this one as well. That's March 31st, so I hope you can attend that one too. If you're not already doing so, check out our website and follow us on social media. We're on Facebook, Twitter, and we have a pretty active YouTube channel where all the recordings like this one are posted. And if you do not get our weekly news updates each Friday, I highly encourage you to join our email list. Just send me an email to ona@ifas.ufl.edu and I will get you added. So no questions today. Ms. Larson did share her contact information at the end of her PowerPoint. And if you wish any questions at all, to follow up with her. And Colleen, I'm going to turn it over to you for just a moment so you can repeat those, your contact info.
If you have any comments or questions, I'd love to hear from you, and thank you again for having me today.